Voyager 1, the furthest distant man-made object from Earth, has just returned a terrifying image that has stunned both scientists and space aficionados. What could these signals mean, and could they foreshadow the end of Voyager's mission? Join us as we explore every aspect the Voyager has learned thus far, as well as the terrifying message and its meaning for the future. The Earth is a massive and beautiful place, yet it is a little speck in contrast to the rest of the cosmos. People have had an insatiable drive to discover more about the wonders of the universe. Since then, human technology made it feasible to launch rockets and satellites into orbit. When we look up at the night sky, we may think we know the world like the back of our hands. We've caught the stars, charted the planets, and even launched probes deep into space to investigate the huge unknown. But what if everything we thought we knew about the cosmos was about to change? Voyager 1 just sent a terrifying image that shocked the entire space industry. That is exactly what scientists are trying to figure out as they get bizarre signals from the spacecraft. Since the 1970s, Voyager space probes have played an important role in humanity's quest to study the outer planets. While not the first of their kind, the Voyager probes were designed to travel even deeper into our solar system. The Voyagers were able to withstand the radiation found orbiting planets, such as Jupiter and Saturn, because of data obtained by predecessors such as Pioneer 10. Their primary purpose was to get precise pictures of these massive planets using flybys manufactured in NASA's Jet Propulsion Facility. Voyager 1 was outfitted with cutting-edge technology, including a top-of-the-line communication system capable of operating beyond the limits of our solar system. Some of these devices, such as the casa grain 12-foot antenna used to send and receive radio waves via NASA's Deep Space Network, are critical to the Voyager mission. In addition to this antenna, this network was expressly developed to ensure that the Voyager space probe communications could be received from any angle of the Earth's rotation. Voyager has a digital tape recorder that could record up to 67 megabytes of data. This was critical because deep space can disrupt signal transmission, and if Voyager is unable to transmit a signal, the saved data can be transmitted at a later time when a direct line of transmission is established, ensuring Voyager stays on course despite the unpredictable radioactive particles found in our solar system's outer regions. The probe included 3-axis stabilization gyroscopes, 16 high hydrazine thrusters, and a computerized reference instrument. All of these things work together to maintain the probe's radio antenna aimed at Earth, ensuring that we get the critical data it delivers back to us. These devices allowed Voyager 1 to keep its antenna pointed towards Earth even in the face of unpredictable and turbulent deep space circumstances. However, running these instruments and systems for decades required a steady supply of energy, whereas previous space probes depended on solar panels to capture solar energy. The Voyager 1 was built with a distinct power supply in mind. Because NASA engineers anticipated that Voyager 1 would eventually travel beyond the range of sunlight, the probe was outfitted with 3 radioisotope thermoelectric generators. These generators held 24 pressurized spheres of plutonium-238, which created heat that was converted to electricity to power the probe's components at the start of its journey due to its half-life of 87 years and slow degradation over time. Voyager 1's RTGS produced approximately 470 watts of electricity, a figure that has fallen by nearly half during the duration of the probe's 45-year trip. Despite the recent finding of unusual signals from Voyager 1, the probe has been steadfast and trustworthy since its launch, giving priceless insights into the inner workings of our own solar system. And far from the sun's protective embrace, the fringe of our solar system appears to be a cold, desolate, and dark place for a long time. Since astronomers preferred to focus their telescopes on the glowing masses of our nearby stars, galaxies, and nebulae, they ignored the yawning space between us and the nearest stars, which was once thought to be a terrifyingly vast expanse of nothingness. These 2 spacecraft, however, have been sending back our first sights of this odd region known as interstellar space for the past few years. No previous spacecraft has traveled as far as they have, and as the first man-made object to leave our solar system, they are exploring uncharted territory billions of kilometers from home. They have shown that beyond the limits of our solar system lies an invisible realm of chaotic planetary activity. According to Michelle Bannister, an astronomer at the University of Canterbury in Christchurch, New Zealand, who studies the outer reaches of the solar system, that region of space is very different from the blackness we perceive with our eyes. when we look at different parts of the electromagnetic spectrum. However, the solar wind, an endless and powerful flow of charged particles known as plasma that emanates from the sun, is what is causing the ruckus. Among the star systems known as the interstellar medium, this wind collides with a mixture of gas, dust, and cosmic rays. Through their efforts, scientists have pieced together that the interstellar medium is composed of ionized hydrogen atoms, dust, and cosmic rays that mix with dense gas clouds. For more than a century, scientists have been working to understand the composition of the interstellar medium with the help of powerful tools like radio and X-ray telescopes. Because the Sun, its 8 planets, and a far-off disk of debris known as the Kuiper Belt are all contained within the heliosphere, a huge bubble created by solar wind as the Sun and its planets speed through the galaxy, the precise nature of where stars are born. But its origins beyond our solar system have remained largely a mystery. This bubble serves as an invisible barrier between the interstellar medium and spacecraft, obstructing the bulk of potentially harmful cosmic rays and other particles. The heliosphere is also unusually large, suggesting that the interstellar medium has a lower density than expected. The Sun moves through space like a boat across water, creating a bow wave, a following wake, and maybe comet-like tails. However, because the voyages left the heliosphere, no information was gathered regarding the tail. The signal response from this region from the Voyager has been carefully watched by scientists. However, they were shocked when Voyager 1 started transmitting worrying data during one observation cycle. The data suggested improbable scenarios that were incompatible with the accepted theories of interstellar physics. Voyager 1's altitude articulation and control system, also known as AACS, was responsible for measuring and calculating the orientation of the spacecraft and its antenna to ensure that the probe maintained a direct line to Earth for the best signal transmission and orientation, according to officials from NASA's Jet Propulsion Laboratory. Because the probe was still able to observe, gather, and transmit data back to mission control on Earth, indicating that it was functioning normally, despite the fact that the data sent back by Voyager 1 was essentially useless due to corruption, scientists were perplexed as to the origin of this terrifying signal and junk data. The fact that the spacecraft has lived longer than its 45-year design life is still amazing. Both Voyager 1 and 2 have reliably communicated data throughout their missions, despite having some systems turned off to save power. It is challenging for mission control to rapidly address any issues that occur after weeks of looking for an answer, as Voyager 1 continues its voyage and travels 14.5 billion miles from Earth with communication delays of over 22 hours. NASA eventually determined the cause of the strange signals coming back from Voyager 1 was the AACS system that was inadvertently sending data through a corrupted computer. Although the data was accurate, the corruption brought on by the outdated system led to the transmission of junk data back to Earth. While mission controllers initially believed this was an isolated incident, there is widespread speculation that a similar situation could occur again due to the possibility that Voyager the 1st of May have encountered some type of cosmic radiation containing charged particles that distorted system commands, leading to the switch to the corrupted computer. But with a twist, even though they have exited the heliosphere, they are still susceptible to many of the other effects of our Sun. For instance, other stars can see the Sun's light with the naked eye. While some comets have orbits that extend all the way to the Oort cloud, a region that is generally thought to be too far away for us to send our own probes, our star's gravity also extends but is content on the heliosphere, holding in place the Oort cloud, a distant sparse sphere of ice dust and space debris. Despite floating in interstellar space, port objects continue to orbit the Sun. Scientists are curious about what else exists outside of the heliosphere as a result of the mysteries and questions that are revealed with each new wave of data from the voyages. Did that spark your desire for space mysteries? Then subscribe to our channel and join us as we uncover the universe's darkest mysteries. Since the solar system's formation, these far-off objects have seldom changed, and they might hold the key to understanding everything from how planets originate to the possibility that life will eventually develop in our cosmos. Also, if you want to learn more about Voyager 1's discoveries, watch Voyager 1 just sent out a terrifying message back to Earth. Thank you for taking the time to watch, and until next time, keep exploring.